Okay, today we're going to talk about 5.6. It's the end of the chapter, so we'll have a chapter test later on this week. And so let's get started with harmonic motion to finish this last section. There's not a lot to it, but I will point out a couple new things as we go on. So hopefully it'll be a little bit of review as we do this. So I'm just going to open up by looking at some problems to review what we're doing, and that's also part of your homework. So let's start with number 6 in the homework. We're on page 456 in this book. So this is y equals 3 cosine of 1/2 t. All right, t is representing time. So what's happening as our trig function is moving over seconds, minutes, hours, whatever it is they're going to tell you. So let me read what it says here. The given function models the displacement of an object moving in simple harmonic motion. Find the amplitude, period, and frequency of the motion. Okay, so let's start right there. Amplitude, all right, you should know what that is. That's 3. And then period, again, it's cosine, so it's going to be 2 pi over k, but we're not going to use k anymore. It's strange. The book switches it to w. It's the exact same thing. They use k as something else in this section. So think of w as k at the moment. Okay, so what was your k? Your k would be 1/2 in the typical trig function. So we're going to say 2 pi over 1/2. So now your k is w, so I'm going to refer to it as w at this point. So 2 pi over 1/2, fraction inside of a fraction, that's 2 pi times 2, which is 4 pi. So we have stretched the cosine curve to 4 pi units long. The next thing it says is, for part A, is the frequency. Okay, so frequency, all you do is flip this over, w over 2 pi, and what do we get? We get 1/2 over 2 pi, again, fraction inside of a fraction, that's 1/2 times the reciprocal, which you get 1 over 4 pi. Okay, so that was part A. Part B is sketch the graph. So as you can tell, the only thing new here is our frequency at the moment. And sketching the graph should be the same as what we've been doing. There is no displacement. Our amplitude is 3. It goes out to 4 pi. Okay, so that's pi all the way to 4 pi. And the frequency just means how often it's happened in a certain amount of time. So it starts here and goes down. Excuse me. Back up and there. So nothing's really changed at the moment. So let's do another example. Next slide. Let's look at number 10. It looks kind of ugly, but it shouldn't make any difference at this point because you guys are good at all the pieces that are here. -3 have sine, and then you have 0.2t plus 1.4. Okay, so obviously this is going to be radians. We have to get rid of the 0.2. That's going to be your k, or in this case, our w. That has to be moved out, so we're going to divide both of these by 0.2. So let's rewrite this. Y equals -3/2 sine of 0.2. And we have t plus whatever 1.4 divided by 0.2 is. Hopefully you can do that. So 14 divided by 2 is 7, and 1.4 divided by 0.2 is 7 as well. Okay, so this is actually going to be displaced to the left by 7 units. And it's going to, since pi is not in here, we're going to use radian measurement to do this. All right, so first, again, we answer the question. We want amplitude. Amplitude is going to be -3/2. Okay. And the negative just means it's being flipped upside down vertically. And our period, the period for sine, simple harmonic motions, basically sine and cosine. The period is 2 pi over w, and our w is 0.2. That's the same thing as 2 pi over 2/10, fraction inside of a fraction. And we get 10 pi. That's our period, our frequency. Just flip this over, and w over 2 pi again is frequency, and that's 0.2 over 2 pi. 2/10 over 2 pi, fraction inside of a fraction. The 2's reduce out, and it's 1 over 10 pi is our frequency. And then part B, we graph it. So since it's moved to the left so far, I'm going to guess that everything's over here, starting at -7. But again, you have to figure all this other stuff out. You're starting at -7, and our period is 10 pi, so we have to divide that by 4s to get each piece. So that's going to be 5 pi over 2 is what we're adding from our starting point. Okay, let's pause there for a second and have you guys try to finish that, and we'll go from there. Okay, so 5 pi over 2, we have to put this as a number, is, oops, let me change this here. You have to put that as a number. That is 7.85, so we'll just do 7.9, okay? Which means this graph is going to go past 0 before it gets to the next point. So we need to change this a little bit. Hold on a second. There we go. We're going to change this to, whoa, that's so not what I want. There we go. That's not it either. What's the deal? There we go. We'll put it here and continue this on. So -7, remember we got to add the period that we divided by 4 times to our starting point. So plus 7.9, that's going to give us a positive 0.9 for our next point. So, and then give equal increments after that. So the first point is just past the y-axis. That's 1, 2, 3, 4. All right, so 0.9 plus 7.9 is going to be 8. 0.8, let's see, 0.9, 8.8 plus 7.9, 15, 16.7, so 16.7, and one more, 23 is 24.6. Okay, so you converted that. Now we go ahead and draw this, but remember your amplitude is -3.5, so it's -1.5, so -1.5 and 1.5. And since we have the negative out in front, that flips the sign upside down, so we still start on the x-axis, but it is now going down instead of up through those points there and there. So that is the number 10 answer with that displacement and the reflection. Right, so not any different than what we've been doing so far. So let's go on to working a problem backwards. Next slide. If we look at number 14, it gives us the amplitude to be 24 and the period to be 2 minutes. Okay, doesn't say frequency at all. So now we work it backwards. Now it starts out, it says find a function that models the simple harmonic motion having the given properties. All right, so simple harmonic motion is going to be sine and cosine is what we're dealing with. Assume that the displacement is 0 at time t being 0, meaning you're still on the x-axis. That's what the displacement, we're not shifting left or right. Our displacement would be if we, like the cosine has a displacement. It doesn't start on the x-axis. So this is, since our displacement is 0, we are using the sine curve, and at time t being 0, we're not shifting left or right. We're starting at 0 on the x-axis. So real quickly, visually, it doesn't say to graph it, it says find the function. Okay, so we know it's going to be the sine function. We're starting there. And our amplitude is 24, -24. It doesn't say you have to do this. I'm just showing you what it is. And our period is 2 minutes. Okay, so it just goes like that. That's your sine curve. And then the question is, what is the actual W we need? So what we're looking at is the amplitude is 24. we know it's the sine curve because the displacement is 0. Now W, what is W? How do we find W? So the period for the sine is 2 pi over W. Well, they're saying that that answer is 2. And so now this just becomes an algebra problem to figure out what W is. Okay? So W goes in this position times T. So let's solve it. Multiply by W on both sides. And we get 2 pi equals 2W. And we now we need to get W by itself. We divide off the 2. So W must have been pi. So our answer would be 24 sine of pi t. Okay, let's do another one just for practice. Let's do number 16. Now these are things I want you to be able to do. It's not too difficult. Again, it's the same thing. The displacement is 0 at time t being 0. So we're not shifting it. That's the time t being 0. And the displacement is 0, meaning we start on the x-axis. So we know this is the sine function. So the amplitude is 1.2 meters. And it tells you now the frequency is 0.5 hertz. Okay, so it doesn't matter about the hertz or the meters as well. So we know it's the sine curve. So right off the bat, we can say 1.2 sine of WT. It's not shifting left or right, so we don't need the parentheses. We just need to figure out what W is at this point. So frequency, remember, was the reciprocal of period. So W over 2 pi for sine. And that is equal to the 0.5. All right, so now we just solve for W. It's an algebra. So we're going to multiply both sides by 2 pi. And W equals whatever 0.5 times 2 is, right? Should be 1 pi. 0.5 times 2 should be 1. Okay? 1 pi. So again, our answer here should be 1.2 sine of pi t. So what am I doing here? You have to know your positions. Your amplitude goes in this position, and you have to figure out what W is. And the only way you can get that is understanding what the what frequency means. And frequency is W over 2 pi. You set that equal to what they tell you the frequency is, and then you solve for W. All right, so let's do a cosine one. New slide. Let's do number 18. Amplitude is 35 centimeters, and the period is 8 seconds. Okay. Instead of distance, now we're talking about time. So that's why it's times t. Now, the instructions say this. Find the model. Simple harmonic motion. Assume that the displacement is at its maximum. That means we're dealing with cosine. So we're starting cosine because we're not starting at 0. But our time is still at 0, it says. So we are starting with nothing shifting left or right. That's what t equals 0 is. Over time, we're still at 0, which means we're right here on the y-axis. Since it's cosine, we're going to be starting at 35. All right, so again, we're given the period. So what do we have here so far? Amplitude goes in front of your trig functions, and it's still WT. How do we get W? You understand period, that is 2 pi over W for cosine, and they tell you what that equals. So the 8 goes there. So now it's an algebra problem. We have to solve for W. So first of all, you got to get W out of the denominator. So 2 pi is equal to 8W, and now we can divide off the 8, and we get W equals pi over 4. So you didn't even need to draw this at all, but I'm just trying to give you an idea of what displacement means. 35 cosine of pi over 4 t. And that's how you do, how you come up with the equation or the function given certain pieces of information. Okay, so at this point, what is our homework? Our homework I want you just to do page 456. You're going to do 5 through 19. The 21 through 27, those are just special formulas where you got to solve some things. It doesn't help unless we're doing some application problems. So we'll do this because I think we need to practice on our graphing and stuff. So we'll go 5 to 19 odds, and then I just don't worry about what it says for phase on these problems. 29. Let's see here. Let's just do 29 through 33. All of that is odds. You're graphing 29 to 33. Don't worry about phase. Okay? You're shifting, you're finding the amplitude and the period. Okay? So make sure you graph those for practice. That's good practice for when we come back. And I'll take answers tomorrow as well, or questions tomorrow as well. Make sure this is due Wednesday by 2:30. All right, see ya.